Okay, guys. Hey, welcome back to my channel, Big Wild Gaming Game Dev Edition. Yeah, so we're gonna getting the topic today is getting these cubes under control. JMonkey Engine 3.0. Cube control. Okay, so I had some difficulty working with this section of the book. I got the code working with the help of AI, but it still needs some modification because an X amount of the generated cubes are supposed to be affected by the player as the player gets within a certain distance of the cubes, causing the cubes to move out of the way. I'm going to continue to work with this with the help of AI and just reviewing the differences of in the AI code and the code that's in the book we're following along in before I move on further in the book. There's some differences in the code between AI and the book. There was really only one slight difference. There was one line which was pretty unimportant, but the code works perfectly fine and does what it's supposed to do. But let's analyze this and get to the bottom of how this really works. First, we're going to talk about packages. And for everything, we're going to utilize perplexity.ai to help us better understand Java. A package in Java is a mechanism for organizing related classes and interfaces into a single namespace. When you create a package, you can use methods and functions in them from other packages as long as they're declared with a public access modifier. But what's a class? A class in Java is a fundamental building block of object-oriented programming that serves as a blueprint or template for creating objects. Okay, so now that brings us to the question, what's an object? An object in Java is an instance of a class that encapsulates data and behavior. And I'll show you these class objects and packages after we finish the reading. So AI's explanation and the human mind. Okay, now that's all very helpful, but is it really understandable to the common layperson? AI's explanation is very accurate, but it's not easily explained, so I'm going to try and simplify it so that it's easier to understand. I'm a college student, so it's not really gibberish to me, but maybe I have some viewers who find it hard to understand, so I'll do the best I can to explain when I show you the code. Controlling these cubes. Okay, so let's discuss controls. Controls are specific classes in JMonkey that dictate the actions implemented on an object through the listener. Controls can be written and reused more conveniently than having to write the same or new code in the simple init app method. There's two classes in this JMonkey game application. We have the main class, which contains the methods that are going to directly affect our game. We then also have a second class called Cube Chaser Control class, which is going to contain methods that can be called by the main class from the simple init app method, which is going to modify objects in our game. And then we also have app states. When a control class is making decisions on the application level, it has then become an app state. But what exactly is an app state? Let's see what Perplexity has to say about it. According to Perplexity, an app state in JMonkey Engine is a powerful mechanism for managing game logic and controlling the overall game mechanics. Here are some key takeaways about JMonkey app states. Purpose. App states allow you to control global game logic. They're used to organize and modularize different aspects of your game. Implementation. They're implemented by extending the abstract app state class, which is a polymorphism. Control classes. A control class in JMonkey Engine is a component that allows you to define and manage the behavior of individual spatial 3D objects in your game scene. So if you want to create interactions between objects, you would create control classes and then reuse them in the primary portion of the game code. So let's take a look at the code. So I'm over here in JMonkey. So now you see over here on the left where it says source packages and then my game and then main. So main, that's the source code here in the middle on the right that I'm highlighting. This is the main Java class. And now what I can do is I can right click my game package, click new, Java class, give it a name like NMU. Give it a name MNU, click finish. And now here I have the NMU class, which I can write a function in here on the NMU and then use it in my main class through packages. So we don't need that, so let's just delete that. Refactor, safely delete. Okay, so we have a class here which is a polymorphism. this is the main class, and it extends the simple application app from from the package right here, simple application. It contains a simple update, simple render, and then we got a main which starts the app right here. It starts the app. And then we have another class called the Cube Chaser Control class, which is also a polymorphism, but this one extends the abstract control class. And this one we have uh, a lot of our features and controls, like we have two instances here. These are private instances. This is an access modifier, which can be public, private, or protected. And it's private, meaning it can only be used within the class Cube Chaser control. We have two of them, cam and root node. And then we have right here is a constructor. A constructor has to have the same name as the class, and it just initializes two variables right here, the cam and root node. And we have also has a control update, which we're going to use to identify the special cubes, and an if statement here. It also has a control render, which is empty, then a clone for spatial, which is going to return the constructor. And then right here we have a third class, cube chaser state, which is a polymorphism, and it's the app state, which extends abstract app state. So here we have some instances. Right here, there's one, two, three, four instances that are private, so they can only be used in this class. And then right here we have an object, the ray object, which is going to be used for clicking objects. And then we got the initialize function, a void update function, void cleanup, and then a geometry my box. Okay, so that's basically the code. Whoops. So now, let me fix that. Okay, so now let's clean and build this, app. Okay, so the build was successful, took 2 seconds. Now we're gonna run it. And the splash screen, this is just the basic JMonkey splash screen, but I'm gonna change the resolution to 640 by 480. I'm gonna also change the splash screen eventually. So you see that cube, how those two cubes are rotating? Those are the special cubes that I was talking about. Those cubes are different from the other cubes because when I get close to those rotating cubes, and there's a third rotating cube, when I get close to those rotating cubes and bump into them, the cubes move. Here, I'll show you. See how the cube is right there. They're like really close to each other. Now, let's bump it up. See, now I bumped the cubes together. And there's 40 cubes from the cube generator. And I bumped those cubes together. Yeah, so stay tuned, guys. It's going to be really great. I have a bunch of new content coming up.